Hey y'all, we're going to look at some more discrete and continuous graphs today. Remember, a discrete graph is a graph that is not connected. It is just a bunch of dots on your graph. The values belonging to a discrete graph are distant and separated, so they're unconnected, just like our points on the graph. Discrete data can be counted sometimes, preceded by the words number of. Okay? Your discrete graph is written in brackets, so remember these are our brackets. No one's perfect at writing them, but the best you can, so it's written in using brackets, and that's called set notation. So written using brackets, which is called set notation. All right, so let's look at some different examples we can get using discrete graphs. So determine if the following examples are discrete. The height of a soccer ball from the ground after it is kicked. So think about the height of a soccer ball from the ground after it is kicked. So if you have a soccer ball and it's here on the ground, you kick it, it goes up in the air, and then it's got to come down. That ends up making a smooth curve. So is that going to be a discrete graph? No, it's not. Remember, discrete graph is not connected. The total cost of staying at a hotel after X number of nights. Remember, a keyword for discrete graph is number of. So this is going to be a discrete graph. There's no connection here. The different number of nights, you're going to have a different cost. The number of pets sold at a pet store in a year, that is going to be a discrete graph. The number of suitcases lost by an airline in a month, that is also going to be a discrete graph. All right, all of these you pretty much know how to find. You know your domain, because we've looked at a lot of these last week. The only thing that might be new is this equation down here and this kind of like word problem right here. So the domain is the set of possible x values, and the range is the set of possible y values. So let's make sure we can go ahead and look to see what we have. So my ordered pair, my domain, my x values. In order from least to greatest, I got -2, 0, 2, and 3. I put my squiggly brackets around there, and that is my set notation for it. My range is my y values. So from least to greatest, my smallest y looks to me like is -7, then -4, then 2, then 8. My table, here is my table. On your table, it usually tells you the top is usually your x and the bottom is usually your y, and you can see that here. X is the number of tickets purchased and y is the total cost. So for my table, they have my domain already in order for me. And they actually, remember, these are your squiggly brackets. I'm not perfect at writing them, but put them around them for set notation. And my y is actually in order from least to greatest as well. Oh, that says $3.50, $7, $10.50, and $14. All right, so when we're looking at our graph, remember I always tell you, you want to make sure you know what the ordered pairs actually are. So I'm going to go here, and the first ordered pair is -1, 1. The second ordered pair is 1, 2. The third is 3, 3. And the fourth is 5, 1, 2, 3, 4, 5, 4. Okay. So I have a -1, a 1, a 3, and a 5 for my domain. -1, 1, 3, and 5 for my domain. My range, in order from least to greatest, in brackets, the lowest range is 1, then 2, then 3, then 4. Now we got a mapping. Remember, your first oval is x, your second oval is y. So negative, it puts it in order for your mapping. It should have your domain in order. So -3, 1, 4, 6. And the range, it may not necessarily have an order, but I can pull the smallest is -13, then -8, then -0.5, and then 9.5. All right, now I want to look at my equation. Now when you're doing your equation, the easiest thing to do with your equation would be to pull up your calculator. So I think I have my calculator on the side here. So I'm going to teach you how to, use this equation. If the domain is these values, what is the range? Well, think about this. Domain is what values? Very good. Domain is your x values. So if these are all my x values, how am I going to find my y? So you can do this one of two ways. It does kind of mean wherever I see x in the equation, I can plug in those values. So for the first value of x, 30 times 0 plus 50. Well, can I solve for y there? 30 times 0 is 0. 0 plus 50 is 50. So that's the first value. So when I inputted 0, my output, or my y, was 50. Now try the next value of y. The next value, of x, is 1. So if I were to plug this in, I get 30 plus 50, which is 80. So my input, or my domain, was 1, and my output, or my range, was 80. So I can check this way for every single one of these points. I have 3 more points here. So let's go ahead and do that. 3 times 2 plus 50. Well, 3 times 2 is 60. 60 plus 50 is 110. So my input was 2. My output was 110. Remember, your input is your y, or your x. Your output is your y. Your input's your domain. Your output's your range. Now I have an input of 3 and an input of 4. So let's input those. 30 times 3 is 90. 90 plus 50 is 140. So my input was 3, my output was 140. I'm going to show you another way on your calculator in 1 sec that you can do this. My last input is 4. So 30 times 4 plus 50. Well, 30 times 4 is 120. 120 plus 50 equals 170. So my input was 4, my output was 170. Another way we can do this, and that's doing it by hand. Another way you can do it is you can go to your y equals on your calculator, clear anything you may possibly have, type in this equation. 30, remember your x is right next to your alpha, right next to the green alpha button is your x, plus 50. So that's the equation. I'm going to hit graph in the top right corner here. That's what the line looks like. I want to look at the table because I want to know the domain and range. So notice how next to the graph button or above it in blue is table. So hit the second blue button and then hit the graph button again to get to the table. Now let's make sure my points match up. My first input, my first domain, my first x was 0. And I got that it matched up with 50, and so do they. My next was 1, and I got it matched up with 80, and so do they. Then 2 and 110. Then 3 and 140, then 4 and 170. So they got the same values as I did, and I can always check myself on that calculator. So let's go ahead and write in for my equation. The domain is the values they gave me, my input values. So 3, 4. And my range ended up being my output, or my y values, which I got 50, 80, 110, 140, and 170. All right, now let's look at the equation that we're given here. Jan's balance on a gift card to Jumbo Juice is $25. John's. He plans to use his gift card to purchase his favorite drink, which costs $2.50. The remaining balance of the gift card is a function of the number of drinks purchased. So he has $25 on his gift card. and he wants to purchase a drink that costs $2.50. How many drinks is he going to be able to get? Okay. If I don't have any idea, I have to let X equal my drinks. And how would I write the equation? Think about a gift card. So I'm going to write y equals, because an equation always starts with y equals. If I start with $25 and I want to buy a drink that's $2.50 each, is that $2.50 going to be added to the 25 or taken away? It's going to be taken away. So 25 minus $2.50 for each drink, but I don't know how many drinks he gets. So minus $2.50x. What's a reasonable domain? Well, let's think about this. Do you think he's going to purchase negative amount of drinks? No, you can't purchase negative amount of drinks. So the reasonable domain, the reasonable amount of drinks, well, first, what if he purchases no drinks? He still has $25 on that gift card. He could purchase 1, he could purchase 2, he could purchase 3, he could purchase 4. That could keep going. He could purchase 100, well, could he purchase 100 drinks? Not necessarily. Okay, what's the reasonable range? Well, let's go over to our y equals. And if I type in 25 minus 2.50x, that's what my graph looks like. So it's going down, it's a negative slope. Let's go to the table. So second graph to get to the table. Remember, he's not going to purchase a negative amount of drinks, so I don't want to look at the negatives. If he purchased 0 drinks, he still has $25 on there. If he purchased 1 drink, how much is left? So you can get your reasonable domain from all of that. So if he purchased 0 drinks, there's $25 left. So there's one range. If he purchased 1 drink, there's $22.50. Notice it's going down, which it's going to. If he purchases 2 drinks, there's $20. If he purchases 3 drinks, there's $17.50. If he purchased 4 drinks, there's $15. And it's going to keep going down. How many drinks can he purchase with this $25 gift card? If he purchases 8 drinks, he's only got $5 left. If he purchases 9 drinks, he has $2.50 left. If he purchases 10 drinks, he has $0 left. So technically, my reasonable domain would be from 0 to 10. It would have to stop at 10. Can he purchase any more than 10 drinks? He cannot, because he doesn't have enough money. Okay, my reasonable range would be from 25 all the way down to 0. So I could keep going down to 0 there. So that would be my reasonable range and my reasonable domain. Your graph, you could plot it, but we saw that it ends up going down. It is a discrete graph because you'd get your ordered pairs, but it shows your graph that goes down. All right, let's go on to continuous graph. Remember, a continuous graph is data that can be connected. The values belong to the set. They can take any value within an infinite or finite interval. They usually requires a measuring device. It's written using inequality notation. So inequality notation, we know it as like interval notation. Okay, so it's continuous. It makes a smooth curve or a line. It's connected. All right, the amount of mass, we're going to try to determine if it's discrete or continuous. The amount of gas remaining in a fuel tank after driving X number of miles. The amount of gas remaining in a fuel tank after driving X number of miles. Now think about this. Is there a way for you to measure that? I know all of you don't drive, but in a car, after you drive a certain number of miles, your gas gauge tells you how much is left. When there is a way to measure it, that is a continuous function. The number of fish in a lake at a given depth. The number of fish in a lake at a given depth. So at every depth, there's going to be a different amount. That is a discrete graph. We're not going to make our own. We'll skip that last one, creating your own. All right, remember domain, you look at the x-axis, range, you look at the y-axis. If I have a less than or a greater than, it is an open circle. If I have a less than or equal to or a greater than or equal to, it is a closed circle. And this is stuff you already know, we're kind of just reviewing. All right, so my domain, my x values, it looks to me like my x-axis, the furthest it goes, is right here at -5, and that's included because it's a filled-in circle. It touches -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. That arrow keeps going. So it's going to keep touching everything over there. So it touches from -5 this way. So that is x is greater than or equal to -5 because it was a filled-in circle. Now let's look at my range, my y values. So my y values, the highest it goes on the y-axis looks like +3. And it's a filled-in circle, so it would be included. +2 touches +1, touches 0, touches -1, -2, -3, -4, -5, -6. Arrow keeps going. If I went down all the way down here to -100, would I touch it? I would. So it touches from 3 all the way down, and those values are less than or equal to -3. Actually, that's not -3, that's +3. So y is less than or equal to +3. All right, your domain on the next one. Looks to me like it starts at 0, because it touches right there. Touches at +1, +2, stops at +3, so it touches between 0 and 3. Remember, that's your interval notation. 0, 3. If it's right on it, remember, it's the line underneath. When it's between two numbers, it's always going to have less than signs. The line underneath just determines if it's an open or a closed circle. Your range, your y values, let me get this. Your y values, your range. So it looks to me like it touches y as 0 because it touches right here and right here. Doesn't go any lower. Touches 20 2 times, touches 40, touches 60 this one time. Does it go any higher than 60? So it goes from 0 to 60, so it's between that interval for a y. All right, let's look at this graph. Now be careful here. It looks like I have an open circle there and a closed circle there. So for my x, my domain, the furthest I go is -5, but keep in mind, that's an open circle. I touch -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So I go from -5 to 5 on the x-axis. That's an open circle, so it's only a less than. That's a closed circle, so it's a less than or equal to. The range. Range, your y values. The lowest it goes on the y-axis is 3. And that's not included because it's an open circle. The highest, then it touches 4, then it touches 5, and then it touches 6, and that's closed. So it's touching from 3 to 6. 3 is not included, but 6 is, because open and closed circles just depend. So it's between the interval of 3 to 6, where 6 is included. All right, last one on this kind, and then we'll look at an equation, a table, and a reasonable domain. All right, so the domain for this graph here. Your domain is your x. Remember, x is 0 anywhere here, and it looks like I touch right there. X is 1 touches, 2, 3, 4, 5, 6, 7, 8, and that arrow looks like it keeps going. So I touch from 0 all the way over. If I went to a +100, I would eventually touch over here. So x is greater than or equal to 0. Your range, your y. What's it doing on the y-axis? Where does it start on the y-axis? So let's see. Y equals 0 right here. Am I anywhere on that graph? I'm not. Y is 30 is right there, and I'm on it. I touch it, y equals 90, I touch it 150, I touch it 210, I touch it 270. This arrow keeps going. If I went all the way up here to 1,000, would I eventually touch? I would. So I touch from 30 all the way up. That's y is greater than or equal to 30. All right, so for my equation, let's go to my y equals. I'm going to put it in my calculator, and I'm going to type in negative 3x plus 4. I'm going to first look at the graph. So hit graph. That is a line. Notice it's decreasing because it has a negative slope. It is a line that goes in all different directions. That arrow keeps going. I can only see a portion of it. So that's going to be all real numbers for the domain and for the range. It is linear, a straight line. When that happens, it's always going to be all reals for the domain and the range. From my table, this should be nice and easy. My domain is my x values, so negative 2, 1, and 2. We put it in order least to greatest. My range is my y values. Least to greatest would be negative 9, negative 5, and 7. All right, let's try a word problem. A 5-foot deep swimming pool drains at a rate of 0.25 feet per minute. The height of the water remaining in the pool is a function of the number of minutes the pool has been draining for. So I start with 5 feet. And it drains 0.25 feet per minute. I have no clue how many minutes, so I'm going to let x equal minutes. If there's 5 feet in the pool and you're draining it, you're taking away. So it's 5 minus 0.25 x. I have 5 feet in there. I'm taking away 0.25 feet per minute. The x is the minutes. I don't have any clue what the minutes are. All right, so let's start by putting it in our calculator. So 5 minus 0.25 x. So keep in mind that this, your x-axis is your time, and your y-axis is the height of the water. Can time ever be negative? It cannot. So if time can never be negative, and time is your x, then you must be starting at 0 for x. So your reasonable domain has got to start at 0. So at 0, it's at 1, 2, 3, 4, 5. So your domain starts at 0. At 1, it's at 4.75. So it's slowly going to start going down. 2, 3 is about, oops, didn't graph my numbers very well. At 0, it's at 1, 2, 3, 4, 5. At 2, it's at 4.75 and 4.5. Then 4.25 for 3. And then at 4, it's literally at 4, which is up a little higher. So it keeps, notice it keeps going down. At 8, 4, 5, 6, 7, 8, it's at 1, 2, 3. So it's slowly going down. When is it going to be at 0? So keep looking here. After 18 minutes, there's going to be 0.5 feet left. After 20 minutes, there's going to be 0 feet left. So it goes all the way from 0 to 20 on your x-axis. So that is your reasonable domain. Your reasonable range, well, we know the highest it goes on the y-axis is 5, and the lowest is 0, because when it's at 20, it's at 0. So it's from 0 to 5 for your y. All right, go ahead and check Google Classroom or your slides to see what you need to do next.